everybody. The topic of this section is present value and discounting. In this section, we will study the concepts of present value and its calculation with compounding more frequently than annually. At first, let's consider two questions. Question 1. How much will we have in 10 years if we invest $1,000 today at an interest rate of 8% per year? This is a question about computing the future value FV. By the compound amount factor, the FV is equal to PV 1000 multiply 1 plus 8% to the 10th. It's about $2,159. But if we need to have $15,000 after 8 years, how much do we have to invest now? In other words, the FV is $15,000, the interest rate I is 8%, and the number of years N is 8. We need to calculate the present value. Take a transform to the compound amount factor. We can get a formula of the PV. From these two questions, we can get that calculating present values is the reverse of calculating future values. That is, in order to have a certain amount in the future, calculating present values tells us the amount we would have to invest today. The process of calculating present values is called as discounting, and the interest rate used in the calculation of the present value is often referred as discount rate. Well, discounting in finance is very different from discounting in retailing. In retailing, it means reducing the price in order to sell more goods. To distinguish discounting in finance and that in retailing, the calculation of present values is called discounted cash flow analysis. Consistent with the notation for FV, the present value factor is defined as a present value from a future value PVFV known in the magnitude of the FV. The periodic interest rate I and the number of compounding periods N is equal to FV over 1 plus I to the nth. Let's do a simple quiz. What is the present value of $10,000 to be received in 4 years at an interest rate of 6% per year? So the FV is $10,000. The number of years N is 4, and the interest rate I is 6%. By the present value factor, the PV is equal to 10,000 over 1 plus 6% together to the 4th. Like the formula of the future value FV, if the interest is compounded more frequently than on an annual basis, that is, the interest is compounded more frequently than once per year, the formula for present value should be modified to PV at FV, APR, N, and M is equal to FV divided by 1 plus APR over M to the mth. Here, APR is the annual percentage rate and M is the number of compounding periods per year. And in the continuous discounting case, the present value formula is PV is equal to FV multiply exponential minus APR multiply N. For example, the present value of $500 in 5 years with semi-annual compounding, that is, compounding every 6 months at a 10% annual rate, would be 500 divided by 1 plus 10% over 2 together to the 2 multiply 5, 10th. And if the interest rate is compound continuously, the present value would be 500 multiply exponential minus 10% product 5. Finally, let's do another quiz. Suppose a $10,000 T-bill that will mature in 3 months is currently selling for $9,800. If you purchase and hold the T-bill to maturity, what rate of return would you earn on this investment computed as a continuous compounding annual rate? So the FV is $10,000, PV is $9,800, and because it is over the 3-month period, N is 3/12. Note that the interest rate is compound continuously. By the formula of PV in continuous discounting case, PV $9,800 is equal to FV $10,000 multiply exponential minus APR multiply 3/12. In this equation, only the APR is unknown. Therefore, solving this equation by algebra arguments, we can find the solution for APR. It's about 8.081%. In summary, we have studied the concepts of present value and the calculation of it under conditions with compounding more frequently than annually and continuous compounding. That's all about this section. Bye.